C2, geometric sequences. Proof of the formula for the sum of a geometric progression. So even though you're given this step by step, I'm going to go through it. So write out the sum. So this is meaning the sum of terms which are written as un, which is equal to a times r to the power of n minus 1. So we've used this quite a lot now. So if I'm doing s of n, well, my first n would be 1 for my first term. So here I would have 1 minus 1, which will give me 0, and r to the power of 0 is just 1. So I end up with just an a term, and then I'll be adding on a times r to the power of 2 minus 1, which is 1, so that'll give me a times r, plus, now my n equals 3, so I'll have a times r to the power of 3 minus 1, which is 2, and that's going to keep going all the way until I'm doing a times r to the power of n minus 2 and a times r to the power of n minus 1. So now I'm asked to multiply the whole thing through by r. So I'm timesing through by r, and this is going to give me r times s of n on this side of the equation, and then I'm going to have a times r plus ar times r, which gives me ar squared, plus ar squared times r, which gives me ar cubed, and so on, all the way up to a times r to the power of n minus 1, plus a times r to the power of n. And now in this next term, I'm asked to subtract these terms from each other. So if I do Sn minus r times S of n is equal to a minus, so I'm doing ar minus ar, so they'll cancel out. Then I'll be doing ar squared minus ar squared, so they'll cancel out. And it's going to keep going like this all the way up to cancelling out the a times r to the power of n minus 1 terms. And then it's going to be minus a times r to the power of n. So I need to tidy this up a bit. So that'll give me Sn, lots of 1 minus r, which is equal to a lots of 1 minus r to the power of n. And then cleaning up by dividing through by 1 minus r. This will give me Sn equals a lots of 1 minus r to the power of n divided by 1 minus r. So as long as you think about these steps here, you shouldn't have to memorize it because you can just work it out for yourself. The proof, that is.